This question comes from Daniel, who asks, if Earth was twice its current size, same composition, same distance from the sun, just twice as large, what would actually change? Great question, Daniel. The answer involves shorter trees, crushed animals, and the uncomfortable realization that Earth's size is not an accident. Let's scale up. The numbers. A Earth twice as big means twice the diameter, about 25,000 kilometers across instead of 12,742. But size and gravity do not scale the same way. Gravity depends on mass, and mass scales with volume. Double the diameter means 8 times the volume and roughly 8 times the mass. Surface gravity would be approximately twice what it is today. Everything on this new Earth weighs twice as much. You step outside and immediately feel it. Walking requires twice the effort. Climbing stairs feels like carrying another person on your back. Your heart works significantly harder just to pump blood upward against stronger gravity. You are not injured, but you are exhausted within minutes. Life reshapes itself. Evolution would have produced a completely different biosphere on a twice as large Earth. The square cube law governs everything. When an animal doubles in height, its weight increases 8 times, but its bone cross-section only quadruples. Bones become inadequate to support body weight much faster on a high-gravity world. Large animals as we know them, elephants, giraffes, whales on land, simply could not exist. Everything would be shorter, denser, wider. Legs would be thicker relative to body size. Necks would be short. Dinosaurs in their largest forms would be impossible. The largest sauropods were already near the physical limit of what Earth's gravity permitted. On a twice as large Earth, they would collapse under their own weight. Trees face the same problem. The tallest trees on Earth, redwoods reaching 115 meters, are already pushing structural limits. On double Earth, trees would likely max out at a fraction of that height. Forests would look low and dense rather than tall and vertical. Even insects and birds face constraints. Flying becomes dramatically harder when gravity doubles. Wings need to be proportionally enormous to generate enough lift. Most bird species as we know them could not fly at all. The skies would be emptier. The atmosphere. A more massive Earth holds atmosphere more tightly. With twice the gravity pulling atmospheric gases downward, the atmosphere would be significantly denser at the surface. Air pressure would be higher. The sky would appear a deeper, richer blue, possibly shifting toward dark blue or even purple at the horizon, depending on atmospheric composition. This denser atmosphere traps more heat. Surface temperatures rise. Weather systems become more energetic. Storms more powerful. Winds stronger. The water cycle accelerates. Rainfall becomes more intense and more frequent globally. The thicker atmosphere also provides better protection from radiation and small meteorite impacts. More space rocks burn up before reaching the surface. In some ways, this is safer. In others, the more powerful weather makes coastal and low-lying areas extremely dangerous. The planet itself. Geology changes completely. With 8 times the mass, internal heat is far greater. Volcanic activity increases dramatically. Tectonic plates move faster. Mountain ranges rise and erode more rapidly. The planet is geologically violent compared to Earth as we know it. There is also a critical threshold problem. Planets above a certain size, roughly 1.5 to 2 times Earth's diameter, tend to accumulate thick hydrogen and helium atmospheres during formation, becoming what astronomers call super-Earths or mini-Neptunes. Our twice as large Earth might have captured enough gas during the early solar system to become a completely different type of planet, with a crushing, thick atmosphere of hydrogen, more similar to a gas world than a rocky one. Whether life could begin and survive under those conditions is genuinely uncertain. The final answer. So what actually happens if Earth is twice as big? Gravity, twice as strong, everything weighs double. You exhausted walking, heart under constant strain. Large animals, impossible. Bones cannot support the weight. Trees far shorter, denser forests. Flying, most birds could not take off atmosphere. Thicker, heavier, richer blue sky. Weather, more powerful storms, stronger winds. Geology, far more volcanic, faster tectonic movement. Risk at this size, Earth might have become a mini Neptune instead. Earth's size is not random. It sits in a narrow range where gravity is strong enough to hold a breathable atmosphere, but weak enough to allow tall trees, large animals, and flight. Shift that size significantly in either direction, and the planet that results is profoundly less hospitable. We live on a planet that is almost exactly the right size. That is not something to take lightly.